So now that we know how to draw any angle in standard position in the plane, we're finally ready to talk about the unit circle definition of the trigonometric functions. So let's first draw a unit circle. So a unit circle is just a circle, it's the circle of radius 1 that's centered at the origin. It's the circle of radius 1 centered at the origin. So here's a circle that's of radius 1 centered at the origin. And if we draw an angle theta in standard position, so let's draw an angle theta in standard position. We know how to do that. I'm just going to draw an angle that looks something close to 120 degrees, so something like this. Here's an angle theta, so this is theta. And what happens, what would we do? How do we define sine of theta here? Or cosine of theta? Or tangent of theta? Well, we don't know how to take the sine, cosine, or tangent of this particular theta because this particular theta exceeds 90 degrees. So what do? Well, we take the point, where this ray, the ray that's not the ray that is the positive x-axis. So you can think of this as the defining ray of this angle in standard position. So we take the defining ray of this angle in standard position, and we look at the point where it intersects the unit circle. Note that this unit circle has radius 1. Radius 1 centered at the origin. So we take this point where it intersects the unit circle, where the defining ray of the angle theta intersects the unit circle, and we make the following definitions. We say that the sine of this angle theta is equal to y, the y coordinate of this intersection point. We say that we define cosine of theta to be the x coordinate of this intersection point, and we define tangent of theta to be y over x, or you could also think of it as sine of theta over cosine of theta. It's the same thing because sine of theta is y and cosine of theta is x. So tangent of theta is y over x. So that's how we define taking the sine of theta and the cosine of theta, where theta is any possible angle. And this definition actually agrees with, that is, if we were to have an angle that's, let's say we had an angle that's less than, or it's in between 0 and 90 degrees. So maybe we have something like this. We have this angle here. We have this angle here. If we were to take the sine and cosine and tangent of this angle alpha, we would get the same values as if we were to draw a right triangle with the angle alpha, and we were to take the sine of alpha, cosine alpha, and tangent of alpha. We would get the same thing, we would get the same results as if we were to determine the intersection point of this alpha with the unit circle, so this ray, the defining ray of this angle alpha. If we were to take this intersection point, x comma y, then this x would be the cosine of alpha, this y would be the sine of alpha, and then this would be y over x. Let me call this actually x prime, y prime, to distinguish it from the x and y over here. So x, y prime over x prime. So we would get the same result. So that's really cool. Now we can take, and since we know how to draw any possible angle in standard position, so now we can take the sine, cosine, and tangent, and also the cosecant, secant, and cotangent of any possible angle, as long as we're careful that the denominators of any of our angles, because remember, like, for instance, cosecant is equal to 1 over sine of theta. So cosecant of theta is equal to 1 over sine of theta for any angle theta. And so we just have to be careful to make sure that sine of theta is not 0. And similarly, we have to be careful to make sure that the x value, the cosine of theta, is not 0 when we're taking the tangent of theta. But other than that, we as long as we're careful about to make sure that our denominators are not 0, we can take the sine, cosine, tangent, cosecant, secant, and cotangent of any angle that we could possibly want using this new unit circle definition. And it also is really nice because it exactly agrees with our right triangle definition for when the angle that we're taking the sine, cosine, or tangent of is in between 0 and 90 degrees.